So let's see, our formula says ax and ay. So ax is a cosine theta and ay is a sine theta, right? Now let's make a question to understand that. Ax is a vector quantity, A is a vector quantity, and A has two components, x and y. So A is a vector quantity and A has a two component, x and y. So let's write a question to understand what I mean, to understand these two mathematical laws of physics. Let's say a projectile fired. A projectile with, say, keep some initial velocity with initial velocity of 100 meter per second, fired to northeast direction at 30 degree. Find the component, find the x and y component of force. All right. So let's see. All right. So ax is a cosine theta. So a is simply the velocity, 100 meter per second, and then cosine theta is 30 degree. So what is 30 degree? Cosine 30 degree? Let's see. Right. So here we have 30 degree, we have 45 degree, we have 60 degree. So here, this is a technique to find the theta. So here you can write 2 is everywhere. So now you write 1, 2, 3, and you write 1, 2, 3, and then you square root everything. All right. So that's the technique. You don't need to memorize everything. You need to memorize the technique, and then you will be able to find the theta that you want. What do you need? What theta you want? You want the 30 degree. So this is our cosine, and this is our sine. Now we need the cosine. Cosine is square root of 3 over 2. So cosine is square root of 3 over 2 is cosine 30 degrees is square root of 3 over 2. Which is then, let's see what we get. 100 times the square root of 3 over 2. $86. So we get 86 toward the x direction. Okay, so if this is x, this is y, and a tank, there is a tank, and it fired 30 degree toward the northeast. All right, the velocity was 100 meter per second. Okay, so now this is a vector. This is a vector quantity. This has a force on this direction and force on this direction. Why this direction? Because the projectile was fired on this direction, but it will fall back to the earth due to the gravity. So that's why it has a two component, and the component that is on x direction is 86 Newton, and the y direction one is a sine theta, which is a sine 30 degree is simply square root of 1 over 2, which is half. So 100 times half, which is 50 Newton. So this direction and the y direction the speed is 50 Newton and x direction is 86 Newton. So that is vector quantity, and we're going to do more example of vector quantity pretty soon. So we just finish with these two beautiful mathematical formulas. Now we're going to take a look the force of friction. How friction contributes. What is the contribution of friction in a force? So the friction is, this is the formula we're going to use. So let's make a quick example. All right. So let's say an object, 10 Newton applied to move a rubber box from point A to B. Calculate the force of friction. All right. So let's see. Mu, we call it mu. We call it normal force. All right. So all right. So if this is a box of rubber, all right. So the normal force is, we have it here, 10 Newton, and we know that kinetic coefficient between the floor and rubber is 68, I believe. I'm not sure, I have to check, but it's around there. So 0.68 times 10 Newton. So force of friction is 6.8 Newton. 6.8 Newton. Right. So that's the force of friction. That's the force of the friction. The friction exerts on the box of rubber and slow it down. What was the force? 6.7 Newton, 6.8 Newton, which is close to 7 Newton, which is quite a force. That's why when we don't exert enough force, things stop, things doesn't move. Not because something else, but because the friction. Right. So we just complete that. So next one we're gonna do it on the next video. We're gonna try to understand the force of gravity, and then we also gonna do the rest of the formulas that we have on the board. So let's stay with me for 2 or 3 more videos, and make sure you don't lose attention, because it is important. Once you finish this course, you should be able to understand every topics of classical mechanics, which is not a which is quite a big deal, because people spend years of study to understand classical mechanics, and we are trying to get everything done in 4 or 5 video tutorials.